After this, there is no turning back. If you take the blue pill, the story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. Remember, all I'm offering is the truth, nothing more.
Welcome to the Matrix. Now today what we're going to be doing is we're looking at matrices, nothing quite as wonderful as Neo was stepping into, but part of the program nevertheless that we need to know. So let's get started. Matrix is the name of the film. When we're talking about matrices, which is plural for matrix. So a matrix basically is just an array of variables or constants, and we enclose them in brackets, and they are lined up in rows and vertical columns. Now, when we discuss matrices, we tend to refer to them by their dimensions. So the way we determine the size or the dimension of a matrix is by the number of rows and the number of columns it has. So we tend to call the matrix, for example, in the diagram here, matrix A has, as you can see, 2 rows and 3 columns. So that would be called a 2 by 3 matrix. So these are some examples of dimensions of matrices. So the first one is a 3 by 2, so you can see that it has 3 matrices. So we've got 3 rows. We've got 1 row, 2 rows, 3 rows, and we have 1, 2 columns. Matrix B is a 4 by 1 because although it's only 1 vertical column, if you look at it, the horizontals, we're looking at 4 rows. So we've got 1, 2, 3, 4. They're all in rows, but we've only got 1 column. And matrix C only has 2 rows but has 4 columns, so we name it as a 2 by 4 matrix. Now the components in a matrix, we tend to refer to them as elements or entries. Now they're the value in a matrix and can be allocated either a number or a constant. Now we number the rows and columns, and we refer to the entries or the elements in the column by the place in the matrix by their row and their column. So the example here, if you look at this first entry here, we have M subscript 1, 1. So the first one refers to it being in row 1, and it is also in column 1. Next, we have M subscript 1, 2, so it's still in row 1, but it is in column 3. And the third one along, again, row 1, but column 3, and so on. So here, second row, all of our subscripts will start with 2. Third row will all start with 3. Now we have a number of different types of matrices that we will be looking at during this course. We have a column matrix, which is only 1 column, and if you think back to the previous one, the 4 by 1 matrix that we looked at a couple of slides back, it's exactly the same thing. It has basically 1 column, but it has a number of different rows. And this one, if we were to refer to this one, we would be referring it as a 3 by 1 matrix, or you could call it a column matrix. And a row matrix has only 1 row, and a square matrix has the same number of squares and rows. So it can be a 2 by 2 or a 3 by 3, 4 by 4, and so on. We also have what we call diagonal matrices. Now this one is a square matrix having all zeros that are not on the leading diagonal. So as you can see here, on our leading diagonal, starting in the top left-hand corner, coming down to the right bottom corner, we have 5, 0, 2, negative 4. They're the entries that we have in this matrix. And all of the other entries in the matrix are zeros. Alternatively, we have an identity matrix, which is a square matrix where all elements in the leading diagonal are equal to 1, and all of the elements in all the other elements in the matrix are zeros. Okay, and we'll get into identity matrices a little bit later on. We also have a zero matrix, which has all elements equal to 0, and this one can be any type. It can be row, column, square, or rectangular. And we also have what we call a null matrix, which is a square matrix where all elements are equal to 0. We will be looking at these a little bit further on. I just want to give you a brief rundown on the different types we're going to look at during this unit of work. Now, when we're talking about matrix equality, they're only equal if they have the same number of rows and the same number of columns, beg your pardon, and their corresponding elements are equal. Now that would mean if we had a 2 by 2 matrix which went from left to right, row 1, 2, 1, and then row 2 would be 1, 4. It's only equal if it's another square matrix, 2 by 2, with the entries 2, 1 in the first row and 1, 4 in the second row. So they have to be identical in that way. The corresponding elements are equal and they have the same number of rows and columns. Now, we can do a number of things with matrices, and the first thing that we're going to look at is we're going to look at the addition and subtraction of matrices. Now, matrices may be added or subtracted if they have the same dimensions, and to do that, all we do is simply add or subtract the corresponding elements so that A plus B equals C. And we'll give you some examples of that. Now, some examples are we've got a matrix here that or two matrices that we're going to add. So if we look, first of all, we need to add the corresponding elements in each of the matrices. So we would have, if you look at the first element in the first matrix, we add it to the first element in the second matrix. So we have negative 2 minus 4, 0 plus 6, and 4 plus 0. Okay, so all we're doing is adding each of these together, and we'll go to the second row. We have 3 plus negative 15, which gives us 3 minus 15, negative 10 plus negative 4, which is same as, I beg your pardon, negative 10 plus 2, and then we have 12 plus negative 4, which is the same as 12 minus 4. And in our third row, we go 3 plus 6, negative 2 plus 7, negative 2 plus 1. So from there, all we have to do is go through and calculate each of these. So negative 2 take 4 is negative 6, 0 plus 6 is 6, 4 plus 0 is 4, and so on. And that gives us the yield, or the sum, of our two matrices. Second example, if we're looking at this matrix, can we indeed add it? Does it have the same dimensions? Well, they don't. So we can't add them because they're of different dimensions. Remember, they have to have the same dimensions. These ones, however, we can. So we're subtracting here. So we will end up with 2 take negative 4. So we 2 take negative 4, negative 18 take 2, 20 take negative 5, and negative 5 take 1. And you can see over here, this is where we've done all our working. From there, we end up with 6, negative 20, 25, negative 6. And next example, similarly, we're going to go -3, take 5, 10, take 4, 2, take 3, -10, take 2, 8, take 1, -6, take 0, 0, take 8, 1, take 10, or -10, and 0, take -4. So it's important to make sure that you write your working out when you're doing these. So take the little bit of extra time to do all the working in a separate matrix, and then you won't get confused with any of the addition or subtraction, or later on when we get to multiplication, you won't get confused by any of that either. Okay, so we're going to leave it at that for today, guys, and we will continue on with matrices in our next lesson.